This is exquisite. In this class, we will be learning about the mirror formula.
Okay.
The mirror formula says that 1 over f is equal to 1 over u plus 1 over v, where f is the focal length of the mirror, u is the object distance, and v is the image distance. Let's illustrate practically what those letters mean. Suppose we have our mirror as usual, with the principal axis, the center of curvature C, the principal focus f, and the pole of the mirror P. We already know that the focal length is the distance from the mirror to the principal focus. Then suppose we have an object placed here, and the image forms here. The letter U represents the distance from the object to the mirror, that is the object distance, while the letter V represents the distance from the image to the mirror, which is the image distance.
In essence, the mirror formula helps us to determine the position of the image if we know the position of the object and the focal length of the mirror.
Yes, we can also use it to determine the position of the object if we know the position of the image and the focal length of the mirror.
And even to determine the focal length of the mirror if we know the positions of both the object and the image.
Great, I will illustrate with some examples in our next classes. But before then, I will show you here how to use the formula on a convention we call RIPP.
RIPP? What's that?
RIP is the short form of real is positive. For example, we use a positive value for V if the image is real.
Okay, that is if the image is formed in front of the mirror.
Good. And on the other hand, we use a negative value of V if the image is virtual.
That is if the image is formed at the back of the mirror.
Great. Same thing goes for the focal length. We use a positive value for f if the principal focus is real.
Okay, that is if the principal focus is in front of the mirror.
And we use a negative value for f if the principal focus is virtual.
That is if the principal focus is at the back of the mirror.
Good.
Sensei. The principal focus of a concave mirror is real, while that of a convex mirror is virtual. Does this mean that f will always be positive for concave mirrors, and negative for convex mirrors?
Yes, that is exactly so. And that is what the RIP convention is all about. We will illustrate with some examples in the next classes, but before then, give me a summary of the things you learned from this class.
Okay. 1. The mirror formula says that 1 over f is equal to 1 over u plus 1 over v, where f is the focal length of the mirror, u is the object distance, and v is the image distance. 2. In the RIP convention, v is positive for real images, and negative for virtual images. F is positive for a real principal focus, for example, in a concave mirror, and F is negative for a virtual principal focus, for example, in a convex mirror.
Great, see you in the next class.